All right, guys, we're going to be doing part 3 here of graphing secant and cosecant. So we're just going to run through some more examples. Yeah, let's go. So first one here, we have y equals -3 secant 1/3 x plus 2. Pretty simple, not a lot of transformations. Actually, the great thing here is there's no phase shift, right? I think phase shift is the hardest transformation to implement, and when we don't have that, it's just going to make things easier for us. All right, let's go ahead and go through it. Again, remember what we're really graphing here in the beginning is a cosine graph, because cosine and secant are reciprocals. So our a value here is -3, so it means an amplitude of 3, and we will be reflected. So we had a reflected graph last time. We are going to be reflected this time. So for cosine, we're reflecting it. We're going to be doing these points like this, starting at minimum, right? So that we get that reflected shape. Pay attention to that. It's worth maybe writing that down to remind yourself, even drawing a little sketch out, because it's easy to forget once you kind of go through everything to just draw a regular cosine graph and forget this reflection. All right, so that's our a value. B value here is 1/3. We actually just had this already, but a b value of 1/3 means that when we calculate the period, 2 pi over 1/3 is actually going to equal 6 pi. Right, same thing as multiplying by 3, so we end up with a period of 6 pi. C, again, there's nothing in here, no phase shift, so we're actually just starting at 0. That's really great. That makes things pretty easy for us. And we do have a vertical shift up 2. Okay, let's scale the y-axis to start things off. So we're going to go a midline at 2, amplitude of 3. So we're going to go up to 3 and down to -1. Well, or sorry, up to 5 and down to -1. So here's our midline at 2, 3, 4, 5. That's going to be our maximum points, and -1 is going to be our minimum points, right? We're going 1, 2, 3 below and 3 above. So good, got that done. I'm going to go ahead and draw in those guiding lines. I didn't do it on the second example before, but I think that it helps line things up a little bit for us, especially if we don't have a gridded graph like this. All right, next is scaling the dreaded x-axis. Fortunately for us, because we do not have a phase shift and we have a relatively easy period here, we have 6 pi and we're starting at 0. So 0 is obviously there at the y-axis, 0. And we need to go out 6 pi away from that. That's how long our cycle is. So we're going to end at 6 pi. Pretty easy there. And then we just need to divide this into quarters. So in the middle, that's our middle point. Half of 6 pi, that's 3 pi. And then our 1/4 point is going to be half of this. That's 3 pi divided by 2. 3 pi over 2. And then here in the middle of this, couple ways you could calculate this. You could average these 2 points. 3 pi plus 6 pi is 9 pi divided by 2. 9 pi divided by 2. So you can do it a couple ways. You could, yeah, that's kind of the easiest though, is just averaging. All right, we have scaled the y-axis, scaled the x-axis. We know what we're doing here. We can just start graphing. Remember, it's a reflected cosine curve. We are starting at minimum. We are ending at minimum. In the middle, we are at maximum. And then at the 1/4 and 3/4 points, we are on the midline. Easy enough, easy enough. And now we are graphing a secant graph. Remember, we're not actually graphing cosine. We're just using it as a tool to graph secant. So at the midline points, that's where we have our vertical asymptotes. So one right here, and then one right here. And I sort of got that one. I'll shift it over just a little bit. There we go. And this is a secant graph. So this is the one where we're going to have one of the full U and 2 of these half U's. So right up here, we'll have our full U shape in the cycle. And then over here on the ends, we're going to have the sort of half U's. So right here, we're going this direction. Remember, technically this graph does, extend out this way. It's just not part of our one cycle. And then same thing over here. half u. And it does extend, it's just that's not part of our cycle. Our cycle starts at 0, ends at 6 pi. That's the cycle we're graphing. Anyway, done. Go ahead and move on to the second example here. I believe it's a cosecant. I hope it's a cosecant. Let's go ahead and clear this and move forward. All right, yes, it is a cosecant, and a fun one at that. So let's kind of take a look at it. So for cosecant, we're going to be pretending that this is a sine curve for kind of the majority of it, and plotting those points that would go with a sine curve with these transformations. Yep, let's just go for it. So our amplitude here is 4. It is not reflected. So not reflected. Well, whatever. Not reflected. I know I spelled that wrong. I'm just going to let it be. So we're going to be plotting a regular sine curve like this, not reflected, to help us graph cosecant. The b value in this case, so remember the b value always needs to be factored out. It's got to be b times x minus c, or plus. Plus is fine too, but it's got to be like this. Currently our b value is multiplied in, so we got to factor that out. We got to factor out the b value from this. So in this case, our b value is pi. Factor that out of the parentheses here. So we have to divide both of these terms by pi. It leaves us with an x. It leaves us with a half. Okay, so our b value is pi, which means that our period is 2 pi divided by pi, which is 2. So our period is 2. So that's a whole number period. We're going to be dealing with not fractions of pi on the scaling. We're actually going to be dealing with whole numbers and regular fractions. That can be easier. Usually it is. Sometimes it's a little tricky, but this should be pretty straightforward. And then the other thing that was revealed to us was the proper c value, right? When we factored this out, we found our c value being plus 1/2 actually means that our c value is negative 1/2. We're going to be moving to the left. We're going to be shifting this to the left. We haven't done a lot of left shifts, so that'll be good. And then, of course, the d value, there's no plus or minus anything on the end of this, so their d value is 0. There's no vertical shift. Our midline will actually just be the x-axis. Okay. We're going to scale the y-axis first. So that's easy enough. No shifts, so we're going to be going up 4 and down 4. So 1, 2, 3, 4. Remember, I didn't want to spread this out too high because our graph of cosecant is actually going to go on top of this or below it. So we're not going to spread out too far because we go above and below these values for our cosecant graph. I will go ahead and throw on those guiding lines just to make it a little easier. So here and here. And remember, we're shifting to the left, so I did extend it to the left a little farther than usual. But yeah. All right. Now it's all about scaling the x-axis. So this part's tricky, though I think with these numbers, it will make a little more sense to you as far as what's going on. So we are having a period of 2, just 2, no pi to that, so just 2. If we take our period and divide it by 4, that's 2 divided by 4. That simplifies to a half. So this scaling is saying that if we just count by half, we should be good. If I compare that to my c value, which is negative 1/2, that's actually fantastic because these match. If I count by halves, I can perfectly represent a negative 1/2 doing that. So anyway, that'll be awesome. So we can count by halves. We're going to start on the left side of our graph. We're going to be starting at negative 1/2, wherever we end up deciding to put that. And yeah, let's figure out where we're going to end. So if we start at negative 1/2 and we add our period, negative 1/2 plus 2 is actually positive 1.5. So this is going to be our end. Okay, so let's kind of scale that out on here. We're counting by halves. We're going to end at 1.5. So we have 1/2. We have 1. And then we have 1.5. or 1.5, however we want to represent that. And then we need to go to the left because actually we're starting at -1/2, so -1/2. There we go. That's the beginning. That's the end. We split this up. Actually, it's split up already for us into these nice quarters, right? We have 1, 2, 3, 4 even increments here. So it's already divided up for us in that way because we actually counted by the period divided by 4 anyway. Okay. Yeah, I kind of scrunched things up close here. I could have spread these numbers out a little bit, but whatever, it'll be fine. Yeah, if we're looking for a perfect, beautiful graph, let's just use Desmos anyway. So for us, it's just kind of getting a representation on the paper. All right, we are graphing a sine, the points for sine. So we're going to be at the midline here at the start and at the middle here and at the end. So all those are our midline points. And at the 1/4 point here, we're going to be up at maximum. And at the 3/4 point, we'll be down at our minimum. Okay, I'm going to have to delete some of this stuff or erase some of this stuff to fit things on here. Because remember, we're graphing above and below this. So, all right, now it's a matter of drawing in our asymptotes for cosecant and drawing in those U-shaped curves for cosecant. So asymptote everywhere, there is a midline value. So here, here, and here. That is not accurate, but I will move that over. Why is that so scrunched up? Looks like I didn't kind of count as evenly as I thought. These gaps are a little wider than these, but oh well. We'll just run with it. So now we have our points that are necessary here, and we can start drawing those U-shaped curves. So up at our maximum, we're going to have a U-shaped curve here. Make sure we approach those asymptotes and kind of run along them. And then down here, same thing. So cosecant, we always have these 2 complete U-shapes on there. A little bit different looking than the cycle for cosecant, for secant. Anyway, that's finished and we're good to go. Hopefully the scaling on the x-axis was not too confusing. Anytime our b value includes pi in it, when we do this calculation of our period, we end up dividing out the pi, and then we end up with these sort of whole number or fractional units on there that don't include pi at all. Sometimes people find that a little bit easier to understand, sometimes a little more confusing, kind of totally just depends on the person. All right, let me go ahead and clear this and just take a peek at the homework here. So the homework is to graph these by hand. So I do want you to create that graph by hand. If you want to use Desmos to sort of help you, you can. You can type these things in there, see what it looks like, mess with different scalings to kind of give you an idea there. But in the end, I do want you to actually put it by hand on paper. The other thing is, especially this first one, if this is not factored out, you got to do that. You got to factor that b out and see what's left over. Because right now, this looks like a phase shift of pi over 2. It's not. We got to factor out that b and see what phase shift is actually left. Good luck. I will see you guys later in class.